Hey everyone, welcome back to the College Algebra playlist. In this video, we're taking a look at linear equations. Alright, so let's get started. Okay, here we go. Linear equations. The first thing we need to do is define what linear means. Alright, a linear equation is an equation in which each variable appears only to the first power, and variables are not multiplied together. All right? So here are some examples of linear equations. All right? 7x minus 21 equals 0 is linear because x is being raised to the first power and x is not being multiplied by any other variables. Okay? Here, this blue equation is also linear because x and y are both raised to the power 1 and they're not being multiplied by other variables. All right? This red equation is linear for the same reason. Okay? But down here, these equations are nonlinear. All right, x squared plus 3x minus 4 equals 0 is nonlinear because of this power 2 here. All right, if it's any other power besides 1, it's nonlinear. Okay? And then here, this blue equation is nonlinear because we have two variables being multiplied together. All right, we can't have that in linear equations. And then here, this red equation, this is nonlinear because of this square root of x here. All right, this is the same thing as x to the 1/2 power. All right, the power is something other than 1, right? It's 1/2, so it's nonlinear. All right. So next, I want to talk about some types of linear equations. All right, let's go through these. Here I have a linear equation in one variable. All right, the general form is ax plus b equals 0. All right, and here's an example. 5x minus 20 equals 0. All right, we could solve this for x if we wanted to, right? And we would get some value. All right, and believe it or not, every equation we've solved so far in this playlist has been linear in one variable. All right, so whenever it said solve for x or solve for y or solve for w, all right, it was a linear equation in one variable. All right, it can be rewritten to match this form here. All right, but just because something is linear does not mean it's the equation of a line necessarily. All right, we solve this, right, and we just get x equals some value. All right, that is a point on the number line. Okay, that's the geometry of this type of equation. It's a point. All right, but this equation, right, if it's linear in two variables, that's the equation of a line. All right, because I have two variables, x and y. Okay, every solution to this equation is a coordinate point that we can put on the axis, right, and then draw a line to connect the dots. All right, so down here though, I have a linear equation in three variables. All right, the variables are x, y, and z. Okay, a, b, c, and d, these coefficients, right, and this constant here, right, these are all constants. Okay, this is the equation of a plane in 3D space. All right, every solution is a point x, comma, y, comma, z in 3D. All right, we're not going to look at this in this playlist. All right, not in college algebra. All right, I'm just including it here to show you that just because it's linear does not mean it's the equation of a line. All right, so let's hone in on these first two types of equations. All right, this is what we're going to take a look at. All right, so let's start with linear equations in one variable. All right, here I have the equation 2x plus 7 equals 19. All right, this is linear, all right, so we know how to solve it. All right, first, we're going to subtract 7 from both sides. All right, we're trying to isolate x. Okay, so then we divide both sides by 2. All right, and on the left-hand side, the 2's cancel. All right, so we get x equals 6. All right, that's my final answer. And if I wanted to visualize this, I would plot a point on the number line. Okay, so a point is the geometry of this equation. Okay, next let's move to linear equations in two variables. All right, so these are equations of lines. Okay, there's three different forms that we need to talk about. Okay, so let's start with the first. Okay, let's start with slope-intercept form. Okay? Here I have 3 lines written in slope-intercept form, right? It's y equals something x plus something. All right? These 3 lines are in the form y equals mx plus b. Okay? Let's take a closer look at the equation here. All right? I have 4 letters, right? But just because something is a letter does not necessarily mean that it's a variable. All right, let's make a distinction here. We've seen this first definition before, all right? A variable is a symbol that acts as a placeholder for an unknown numerical value that can change, all right? But a parameter, on the other hand, is a number that determines which specific equation we have, but does not change within that equation, okay? So if we have an equation in slope-intercept form like this, x and y are the variables, and m and b are parameters, all right? Those are just constants that we assign to the equation, right? And based on how we tweak those values, right, that's what changes the graph of the lines, all right? So y and x are big picture, and m and b are small tweaks that we make to the equation, all right? So let's hone in on these. All right, what's going on with these parameters? All right, m is the slope. The slope of the line measures how steep it is, all right? And b is the y-intercept. All right, we'll talk more about that later. For now, I want to hone in on the slope, all right? The slope of a line m represents the change in y over the change in x, okay? Given 2 points with these coordinates, the following formula determines the slope of the line containing these points, all right? This is the famous slope formula, all right? If you have 2 points, you can take their coordinates and slap them into this formula, all right, and it'll give you the slope, all right? So let's do that right now, all right? Let's find the slope of this line. We have 2 points, okay, so we can find the slope. The slope measures the rise over the run, okay? So I'm going up by 2 and to the right by 3, okay? The slope is the change in y over the change in x, okay? So the difference of the y values, we get 5 minus 3 over the difference of the x values, which is 6 minus 3. So that gives us 2/3, all right, which we refer to as the rise over the run. Okay, we rise by 2, we go over by 3. Okay, so up is positive and to the right is positive. Okay, let's talk about the slope just a little bit more. All right, if the absolute value of the slope is large, then the line is steep. Okay, but if it's small, then the line is not steep. Okay. Furthermore, if m is positive, then the y values increase from left to right. Okay, so if you look at a graph and you read it from left to right, like it's a sentence in English, all right, the y values of the points are going to increase. All right, the heights of the points increase. Okay, but if m is negative, then the y values decrease from left to right. Okay? Here are some examples of lines with positive slopes. Okay, we move from left to right, and we can see that the y values are increasing. Okay, but with negative slopes, right, with these blue lines, we move from left to right, we can see that the y values are decreasing. Okay, so let's talk about the y-intercept a little bit more. All right, we know that at the point where the line crosses the y-axis, we have x equals 0. Okay, the horizontal position is 0. All right, plug x equals 0 into the equation to find the y-intercept. All right, we've done this before. We know what we're doing. All right, so we plug a 0 in here, right? And we get y equals 0 plus b. Okay, so just y equals b. All right, we have x equals 0 and y equals b, which means 0 comma b is the y-intercept. Okay, so in summary, given an equation of the form y equals mx plus b, we have the equation of a line with slope m, where these 2 points are any 2 points on the line. Okay, we also have the y-intercept equal to 0 comma b. Okay, so this is what's cool about the slope-intercept form. All right, if we have an equation in this form, we can just look at it and immediately extract info about it. All right, we get the characteristics of the line. Okay, this number next to x, m, right? We can say right off the bat that m equals this. Okay, that's the slope. And we can say that b is the y-intercept. All right, we know where it crosses the y-axis. Okay? Here we're asked to graph the equation y equals 3/4 x plus 1. Okay? So right off the bat, right, we can just look at this equation and immediately say, hey, this line crosses the y-axis at 0, 1. Okay? And we only need 2 points to draw the equation of a line. Okay? So we can use the slope to get a second point. All right, the slope is 3/4, so we have rise over run equals 3/4. All right, so let's start at this point and let's rise by 3 and run by 4. Okay, that gives us 4, 4. Okay, so we can draw the line. Okay, so this is great. We have slope-intercept form now. All right, but now let's talk about point-slope form. All right, this one is a little different. Okay, here's what the form looks like. Okay, we have variables x and y, and we have parameters m, x1, and y1. Okay, let's hone in on these parameters. M is the slope again. Okay, and then x1 and y1 are the coordinates of a point on the line. Okay, so we have the slope of the line and we have a point. All right, here's an example of an equation in point slope form. All right, we can just look at it and extract info. All right, we look at it and we see that this number here and this slot, right, that's the slope, that's 2. And we can also look at these numbers here, right, and say those are the coordinates of a point on the line. All right, 1, 3. All right, with this blue equation, right, this is also in point slope form, but we have to be careful. All right, it's easy to make a sign error. All right, the slope is -5. All right, but the coordinates of a point on the line, right, it's going to be 6, -4. All right, why is this -4 here? All right, look at the formula. These subtractions are baked into the formula. All right, so we have to subtract something here. All right, in order to get addition here, we have to have had subtracted by a negative number, right? This is y minus -4. Okay, which is y plus 4, which is what we have. So y1 is -4. All right. Let's look at one more example to make sure we've got this. All right. In this line, right, the slope is 8/9. Okay. And the point on the line is -10, 7. Okay, so this is x minus -10. All right. And then y minus 7. Okay, so x1 is -10 and y1 is 7. Okay, great. Here we're asked to find the equation of the line with slope m equals -3 passing through the point 4, 8. All right, and we're also asked to report the final answer in slope-intercept form. Okay, there are 2 approaches to this that I want to talk about. All right, in the past, my students have seemed to prefer approach number 1. All right. Me personally, the way I was taught to do this, that's approach number 2. That's the approach I like more. But I'll show you both of them, and then you can decide which approach you like more. All right. With the first approach, we start with point slope form, and then we isolate y to get slope intercept form. All right. But with the second approach, we just start with slope intercept form, and we find values for m and b. All right. So let's try approach number 1. Okay. We're starting with point slope form, right? We have the slope and we have a point on the line. Okay, so we can just plug these values into the equation to see what we get, right? The slope in blue here is -3, all right? x1 in red is 4, and then y1 in green is 8, okay? So the next step is to distribute on the right-hand side, right? I get -3x, and then I get -3 times -4, so that's +12, okay? To isolate this y, let's add 8 to both sides, okay? And we get y equals -3x plus 20. All right, that's our final answer, okay? Let's try approach number 2 to see if we can get the same answer, all right? So here we just start with slope-intercept form, all right? And we say, hey, the slope is -3, all right? But I don't know what b is yet, all right? I have to find b, okay? So to find it, what we do is we plug in m equals -3 in blue here, right? And then we say, this is a point on the line, right? So that means it satisfies this equation, all right? It gives us a true equation. All right, so we can plug in x equals 4 and y equals 8. All right? And then we isolate b on the right-hand side. All right? So we add 12 to both sides to do that. And we get b equals 20. All right? So we have m equals -3 and b equals 20. All right? Those are the two pieces we need to formulate our equation in slope-intercept form. All right, we get y equals -3x plus 20. That's the same answer that we got from approach 1. Okay, great. The last form we need to talk about is standard form. Okay, another way we can represent the equation of a line is in standard form. All right, this form is a little bit useless, okay, because unlike the first two forms, we can't just look at it and extract meaningful info. All right, this is just another way to represent a line, all right? So we need to know about it in case we're asked to convert between the forms, all right? So here are some examples of equations in standard form, right? A, B, and C can be any real number, all right? And x and y are the variables, all right? So we'll close the video with this problem here. All right, find the equation of the line with slope -6 passing through the point 1/4, -2. Report the final answer in standard form. All right, so let's try approach number 1. All right, let's start with point slope form. All right, and then convert. All right, we can just plug in our values, right? M is -6, x1 is 1/4, and y1 is -2. Okay. So on the left-hand side, we have y plus 2. And then on the right-hand side, we have -6x. Okay, we're distributing. So -6x plus 6/4. All right, 6/4 reduces to 3/2. All right. So now we need to get the business with x and the business with y on the left-hand side, right? That's standard form. Okay, so let's add 6x to both sides. And we get 6x plus y plus 2 equals 3/2. Okay? We almost have what we want, right? We almost have this in standard form. We just need to take this constant to the right-hand side. Okay? To leave us with 6x plus y on the left-hand side. All right? So we'll subtract 2 from both sides. And we get 6x plus y equals 3/2 minus 2. I'm going to write that as 3/2 minus 4/2. All right, I'm getting a common denominator. Okay? So that leaves us with 6x plus y equals -1/2. All right, this is in standard form. Right, this is ax plus by equals c. Okay, so this is my final answer. That does it for this video. Thank you for watching, and like and subscribe.